Myself, Y. Justin Leo, Assistant Professor of Department of Engineering, Rogini College of Engineering and Technology, welcome you all for the Non-Destructive Testing and Evaluation course. And this non-destructive testing evaluation elective subject for the mechanical engineering students. So here we'll be studying about the surface NDE methods in Unit 2, and there are two methods. So the first one is the liquid penetrant testing, and the second one is the magnetic particle testing. So Unit 2, in the surface NDE methods, liquid penetrant testing will be studying about the principles and the various types, the properties of liquid penetrants, developers, and advantages and limitations, applications of various liquid penetrating testing methods, and its testing procedures and interpretation of result. And in the magnetic particle testing, we'll be studying about the theory of magnetism, the inspection of materials, magnetization methods, interpretation and evaluation of test indications, and we'll be studying about the principles and methods of demagnetization and also the residual magnetism. So coming to the liquid penetrant testing, this liquid penetrant testing is a non-destructive testing methods that builds on the principle of visual inspection. And this testing increases the seeability of small discontinuities that the human eye might not be able to detect alone. So here in the diagram you can see the discontinuities, and in the second diagram you can see the identification by means of liquid penetrant testing method. So how does this penetrant testing work? In penetrant testing, a liquid with high surface wetting characteristics is applied on the surface of the component which you're going to test. So this liquid is nothing but the penetrant. The penetrant penetrates into the surface, breaking these continuities due to the capillary action and other mechanisms. And the excess penetrant is to be removed from the surface, and then a developer is applied which will pull out the penetrant back to the surface. So with good inspection techniques, visual indications of any discontinuities present become apparent. So these are all the testing procedures of liquid penetrant testing, or the stages of liquid penetrant testing. The first stage is the pre-clean preparation, surface preparation, and the second is penetrant application. The third is excess penetrant removal. The fourth step is developer application, and fifth is examination and interpretation of evaluation of result. The sixth one is the post-cleaning process. So these are all the diagram. The first stage is cleaning of the dry component, and the second is apply a penetrant, and the green color indicates the penetrant on the test specimen. The third is the removal of excess penetrant, and you can see from this diagram the excess penetrant on the top of the surface of the test specimen is being removed. And fourth is apply developer, that is the light green color. You can see on the top of the test specimen, that is, and fifth is examination and evaluation of the defect, and the last stage of the post cleaning of the component. So we will be studying this different now. The first is the pre-cleaning or surface preparation. So normally the parts must be free of dirt, rust, scale, oil, grease, etc. to perform a reliable inspection. So this process is to remove the contaminants from the surface of the part and the defects. So second is the penetrant applications. So you can see from the diagram there are different methods of application of penetrant. First, brushing, and second one is by using spraying, and the third you can see by dipping or immerse, flow on, and more. And once the penetrant is applied, a sufficient time is allowed for the penetrant to enter into the discontinuities which are open to the surface, and this time is called the dwell time. And this is the diagram which shows the penetrant is entered into the defects from the surface of the test specimen. And the third step is a removal of excess penetrant on the surface of the test specimen. So here you have different methods for removal of penetrant. The first is water washable, solvent removal, post emulsifiable. Washable, you can see from the diagram, like a course of water is sprayed on the test specimen to remove the excess penetrant. And the second method is the solvent removal. So here the part is being wiped with a clean dry cloth to remove the bulk of the excess penetrant. And after that, a cloth is lightly damped with the solvent is used to remove any remaining penetrant on the face. So suitable flash time may be required to allow excess solvent to evaporate. And the third is the post emulsifiable. So this is concerned by removing much of the defect from the defect. And here you can use an emulsifier system. This involves an additional step in which an emulsifier is applied to the surface of the part after the penetrant dull drying. The emulsifier is given just enough time to react with the penetrant on the surface, and after that it is being washed with water, and enough time is allowed to diffuse into the penetrant trapped in the defects. And the fourth step in liquid penetrant testing is the developer application. So on the type of developer, the primary methods involves dry, wet, and non-aqueous wet. So this developer application is you're applying developer on the test specimen once the penetrant is being applied. So this penetrant will drag out the penetrant inside the test specimen, and thus the defects can be identified visual inspection. So the dry powder developer, here prior to applying a dry powder developer, the component must be dried properly. So the drying is accomplished in a hot air circulating oven, and after that the developer is applied by immersing the part in the powder or by dusting of the part with the powder, or you can place the part in a developer dust cloud chamber also. So wet developers are applied by spraying the part or by immersing the part while it is in wet condition itself. The part is completely coated and the excess liquid is allowed to drain to prevent pooling, and the part is then dried in a hot air circulating oven. And the non-aqueous developer is usually applied by spray, aerosol spray. You can see from the diagram figure. So a thin even coating can also be applied. The coating should be normally white but still slightly transparent in order to perform a dye penetrant inspection. And this can be even be thinner when performing a fluorescent penetrant inspection. And the fifth stage is examination, interpretation, and evaluation. So here the inspector would evaluate the penetrant indication against specified accept, reject criteria and attempts to determine the origin of the indication. And this very important step of evaluation is to document finding on an inspection report or other record keeping form. And this may be supported with the drawings or photos of indications, etc. And the last step is the post-process cleaning. And this is the final step in the penetrant inspection process, in which the part is cleaned properly after testing to remove all the penetrant processing material, because the residual materials could possibly affect the performance of the part or affect its visual appeal. So interpretation of result. So you can see here the defects, that is casting porosity, and the description is spherical surface indication, and casting cold shut will be indicated in dotted lines, the cracks straight continuous surface lines, and the defect hard tears may be in the form of ragged line of variable width. The defect heat treat cracks will have multiple irregular lines. The thermal cracks will have interconnecting lines. Lack of fusion will have broken line of varying width. The fatigue cracks will have continuous line in parts. And coming to the applications of a liquid penetration, this method is being used in aerospace, where typical components are checked by this method, which includes the turbine, rotor disc blades, aircraft wheels, castings, forged parts, and welded assemblies. And it is being used in automobiles, where most of the parts, particularly aluminum castings and forgings, including the pistons and cylinder heads, are subjected to form of quality checks before assembling them. And it is being used in railways. It is used to find out the fatigue cracking for regular in-service examination of the bogie frames of railway locomotive and the rolling stock. And liquid penetrant testing inspection is used for two ways: for drilling rays, drill pipes, castings, and drilling equipments inspected. Inspections on reactors and tanks. So tanks, vessels, reactors, piping, diodes in chemical, petrochemical industries. This types of liquid penetrant testing inspection is carried out. So coming to the advantages and limitations of liquid penetrant methods. The advantages are: the liquid penetrant testing method is simple and inexpensive. It is versatile and portable. It is applicable to ferrous, non-ferrous, non-magnetic, and complex shaped materials which are non-porous and of any dimension. Normally it's used to detect cracks, seams, lack of bonding, etc. And the limitations are: it is detect only surface flaws, so non-porous surface for material. Surface cleaning before and after inspection is required, and the deformed surfaces and surface coatings prevent detections. So with this, we'll come to an end with this liquid penetrant testing method. So thank you and have a great day.